We have the sine curve from x equals 0 to x equals pi. This region is rotated about the y-axis to form a solid. We want to find the volume enclosed by this solid. The sine curve creates a smooth, asymmetric surface when rotated about the y-axis. The solid tapers at both ends because sine starts and ends at 0. In the xy plane, the region under the sine curve is bounded by 0 and pi on the x-axis. When we look at a horizontal slice at height y, the sine curve crosses at 2x values, the inverse sine of y on the left, and pi minus the inverse sine of y on the right. Since the sine curve has 2x values for each y between 0 and 1, we use the washer method. The outer radius is pi minus inverse sine of y, and the inner radius is inverse sine of y. After expanding and simplifying, the area simplifies to pi times the quantity pi squared minus 2 pi times inverse sine of y. Set up the integral from 0 to 1. The antiderivative of inverse sine of y is y times inverse sine of y plus the square root of 1 minus y squared. Substitute the bounds. At y equals 1, inverse sine of 1 is pi over 2, giving pi cubed minus pi cubed, which is 0. At y equals 0, we get negative 2 pi squared. Subtracting 0 minus negative 2 pi squared gives 2 pi squared. The final volume is 2 pi squared. This reflects the geometry of the solid. At each height y, the washer extends from a small radius on the left to the maximum radius pi on the right. And the accumulation of these washers from y equals 0 to y equals 1 produces a volume of 2 pi squared.